Hello students, continuing our lectures on MEMS resonator sensors. So we'll first now in this lecture we'll talk about its geometry of the resonator and the target mass. So the resonator actually is a square pedestal, as we have told in our last YouTube video. So if you would like to see, then look into the our YouTube video, last YouTube video. Number 246, where an introduction about this geometrical of this MEMS resonator sensor has been given. So here we will discuss about its geometry. So it is actually a square pedestal. Of size 60 into 60 micrometer. So it looks something like this. And it is suspended by 4 beams. 1, 2, 3 and 4, and let's say they are 60 into 60, and they all have got a fixed end. Fixed end. Now, so the dimension of the 4 beams, suspended 4 beams, springs have got dimensions of 80 micrometer, these springs. So this is 80, and width is 4 micrometer. The edge of the pedestal, that means these values, these edges, they are chamfered around size 2 micrometer. And the thickness of the silicon device, which has got a thickness of 2 micrometers. Now this pedestal
बाबा, सबसे अच्छा और कम झिकझिक में पर्सनल लोन कहाँ मिलेगा?
बेटा, तुम्हारा सिबिल स्कोर अगर
So this pedestal, there is an oscillation. It oscillates. The vertical dilation the vertical direction while vibrating. And the four ends, as we have previously told, so these four ends this one, this one, this one, and this one, these four ends are fixed to the substrate on which this device is mounted, that is the silicon substrate. So this is the geometry of the resonator. Coming to the geometry of the target mass. Is actually a simplified sphere it is assumed to be as a sphere, the mass, and it is partially attached to the device. And it is the volume and the cross section are estimated by image analysis and from confocal dark field microscopy images. And so there is blue and red. So this is how this sphere, there is nothing special about it, and it is only assumed to be a sphere because sphere has the lowest surface area.
स्मॉल टॉक अवॉइड करने के लिए अवॉइड करो आई कांटेक्ट. मत देख मत देख मत. अरे देख लिया. चल अब कुछ स्मार्ट बोल. अरे बोल जल्दी.
गोइंग फॉर लंच.
इट्स लंच ब्रेक. गया तेरा प्रमोशन. स्मॉल टॉक करना बहुत मुश्किल है पर ग्रो ऐप पे इन्वेस्ट करना बहुत आसान. जस्ट डाउनलोड ग्रो.
Now the resonant frequencies obtained after the finite element analysis were 170 plus minus 48 kilohertz. It was in air, and 59.6 plus minus 32, or we can rather say, if we do go into the details, it was 170 plus minus 48 in air, and 60 plus minus 3 liquid. Now, through the sensitivity analysis of the multiple parameters in the experiment, there exists 3 parameters that affect dominantly on the resonant frequency of the resonator. So 3 parameters are very important which affect these resonant frequencies. These 3 parameters are the Young's modulus, then the thickness, and of the resonator, and The third one is the fluid density. So the first two are characteristics of the resonator, and the last one is of the fluid. Now, the Young's modulus of the silicon varies in different directions in the material relative to the crystal orientation, and basically we usually take this silicon 100 is taken, and it is assumed to have a modulus of 169 GPa. And now this direction is for the parallel to flat, and if we go 45 degrees to the flat, then it changes to 130 GPa. So it is parallel to the flat, and it is at an angle of 45 degrees to the flat. Now, coming to resonator thickness, the possible range of thickness of the resonator is it's usually 2 micrometer. You can say the resonator thickness is assumed to be around 2 millimeter with slight variations. Now, the density of the fluid is analyzed so that we can confirm the resonant frequency of the device is well matched with the experiment and proceed to study. So the resonator is submerged in a cell growth medium. The medium is taken as L15 medium with 30%. It's called fetal bovine serum, FBS, a fetal bovine, it's a liquid. So the density range of the fluid is 998 with slight deviations plus minus 50 kg per meter cube. Now, by changing the fluid density with 5% or 10%, the resonant frequency of the device in the growth medium is changed. So a change in 5% will change the resonant frequency of the device.